Today, let's talk about data encryption standard. The data encryption standard is a symmetric key algorithm for the encryption of digital data. Although its short key length of 56 bits makes it too insecure for modern applications, it has been highly influential in the advancement of cryptography. So, let's talk about the topics we will learn from data encryption standard. In the following outline, we will discuss the DES analysis, weaknesses, multiple DEs, and security of DEs. In multiple DES, we have double DES and triple DES. And when it comes to the security DES, we have brute force attacks, differential cryptanalysis, and linear cryptanalysis. Encryption is the method by which information is converted into the cryptographic key that hides the information's encrypted data. Data encryption standard is what it stands for. The DES algorithm can be cracked using certain devices. A key with a 56-bit size is used by the DES algorithm. The DES creates a block of 64-bit ciphertext using this key after receiving a block of 64-bit plain text as input. Although the majority of people were aware that military and intelligence groups employed specialized codes or code equipment to communicate, there was little public comprehension of cryptography in the early 1970s. To safeguard computer data and enable extensive commercial interoperability, the National Bureau of Standards, NBS, as NIST was then known, launched a mission to create the Data Encryption Standard, DES, in 1973. DES structure. The encryption process is made of two permutations, P boxes. 1. Initial and final permutations. 2. 16 Feistel rounds. The initial and final permutations are straight permutation boxes, P boxes, that are inverses of each other. They have no cryptography significance in DES. DES is a block cipher and encrypts data in blocks of size of 64 bits each, which means 64 bits of plain text go as the input to DES, which produces 64 bits of ciphertext. The same algorithm and key are used for encryption and decryption, with minor differences. The key length is 56 bits. The heart of DES is the DES function. The DES function applies a 48-bit key to the rightmost 32 bits to produce a 32-bit output. The function is made of 4 sections. DES analysis. 2 desired properties of a block cipher are 1. Avalanche effect. 2. Completeness. Avalanche effect means a small change in plaintext results in the very great change in the ciphertext. Completeness means each bit of ciphertext depends on many bits of plaintext. During the last few years, cryptanalysts have found some weaknesses in DES when keys selected are weak keys. Weaknesses in cipher design. 1. Weaknesses in S boxes. 2. Weaknesses in P boxes. 3. Weaknesses in key. Design criteria. S box. The design provides confusion and diffusion of bits from each round to the next. P box. They provide diffusion of bits. Number of rounds. DES uses 16 rounds of Feistel ciphers. The ciphertext is thoroughly a random function of plaintext and ciphertext. In cryptography, an S-box, substitution box, is a basic component of symmetric key algorithms which perform substitution. In block ciphers, they are typically used to obscure the relationship between the key and the ciphertext, Shannon's property of confusion. In many cases, the S-boxes are carefully chosen to resist cryptanalysis. Here is the example for S-box. The input to S-box 1 is 100,011. What is the output? Answer. If we write the first and the sixth bits together, we get 11 in binary, which is 3 in decimal. The remaining bits are 0001 in binary, which is 1 in decimal. We look for the value in row 3, column 1, in table, S-box 1. The result is 12 in decimal, which in binary is 1100. So the input 100,011 yields the output 1100. An initial permutation is required only once at the starting of the encryption process. In DES, after the complete plaintext is divided into blocks of 64 bits each, IP is required on each of them. This initial permutation is a phase in the transposition procedure. The initial and final permutations are straight permutation boxes that are inverses of each other. They have no cryptography significance in DES. The initial and final permutations are shown. Expansion p-box. Although the relationship between the input and output can be defined mathematically, DES uses the table to define this p-box. Compression p-box. A p-box with n input and m output, where m less than n. Some of the inputs are blocked and do not reach the output. Multiple DES. Multiple encryption is a technique in which an encryption algorithm is used multiple times. In the first instance, plain text is converted to ciphertext using the encryption algorithm. Double DES. In this approach, we use 2 instances of DES ciphers for encryption and 2 instances of reverse ciphers for decryption. Each instance uses a different key, the size of the key is doubled. However, double DES is vulnerable to meet-in-the-middle attack. Triple DES. To make triple DES compatible with single DES, the middle stage uses decryption in the encryption side and encryption in the decryption side. It's much stronger than double DES. Security of DES. The data encryption standard is a symmetric key algorithm for the encryption of digital data. Although its short key length of 56 bits makes it too insecure for modern applications, it has been highly influential in the advancement of cryptography. 3 are of interest: brute force, differential cryptanalysis, and linear cryptanalysis. Brute force attack. We have discussed the weakness of short cipher key in DES. Combining this weakness with the key complement weakness, it is clear that DES can be broken using 255 encryptions. Differential cryptanalysis. It has been revealed that the designers of DES already knew about this type of attack and designed S-boxes and chose 16 as the number of rounds to make DE specifically resistant to this type of attack. Linear cryptanalysis. Linear cryptanalysis is newer than differential cryptanalysis. DES is more vulnerable to linear cryptanalysis than to differential cryptanalysis. S-boxes are not very resistant to linear cryptanalysis. It has been shown that DES can be broken using 243 pairs of known plaintexts. However, from the practical point of view, finding so many pairs is very unlikely.